Everybody, just want to welcome you to week 13, module 13 for your ME 144 heat transfer course. So within our module 13, we'll be wrapping up chapter 7, taking a look at mass transfer, going through a few example problems and my hand solutions as well for these problems. So within this module, we have a lot going on. This will be your last busy module this semester, so we push through, we're right in the home stretch. But within this module here, you do have your quiz number 13. This is posted to Blackboard and it'll be due by Friday at 4 p.m. You also have your final homework, homework number 5. This will be assigned on Monday morning, and it'll be due the following Monday the 3rd at the end of the day. You also this week have on Tuesday your exam number 2. So this will be Tuesday, April 27th. It'll be given between the hours of 9 a.m. to noon, but you'll only have 2-hour block to complete this exam. The reason I give a 3-hour block is just in case you have a class before or a class after the exam. It gives you a little bit of wiggle room of when you start and finish, but it needs to be finished between that 9 a.m. and noon time block. And once you start it, you only have 2 hours to complete it. And the last thing we're going to take a look at here is your group project assignment is due. So this is where you'll be turning this in on Thursday through Blackboard by the end of the day, Thursday the 29th. And this is where you'll be handing in your group's problem and your solution to your group's problem through the Blackboard assignment. Now, a reminder, as always, I do have office hours scheduled on Mondays from 9 till 10 a.m. If you're unable to make it during this time, just send me a chat, an email, or a message, and we'll find a time that does work with both of our schedules. Also, though, our TA does have office hours on Mondays and Wednesdays from 11 to noon. So you have 3 different opportunities to come with any questions you have related to content, homework, grading. Now, if you do have grading questions or homework questions or questions from your exam, the TA is the one who is grading those. This is a great opportunity to reach out to him and go to his office hours to answer any of those questions related to that. So now let's take a look at our schedule for the remainder of the semester. We're getting towards the final stretch here, only a couple more modules left and we're done. So we can see they're down here now in our module 13. So as we can see on the 27th, this is our exam number 2 during that time slot we just discussed. Also, you are going to have your homework number 5 assigned this week due the following Monday. And this is also the week when you're going to be turning in your group project problem as well through Blackboard. So the material we're covering, this is going to wrap up our chapter 7 in our textbook here. This is going to cover external flow for mass transfer. And that wraps up our week 13. So for week 14, the beginning of the week, that's when you turn in your homework 5. The rest of this time slot for these last final 3 lectures of the semester, these are going to be dedicated to your group project presentations. So what you'll be doing is the problem that you made for the other groups, you'll have your solution to it, and you'll be creating a video of you stepping through your solution, similar to what I do in class as I go through the example problem. So that's what you'll be turning in, and I'll be posting your videos on Blackboard during the in the slots for the lecture materials for these last 3 sections of the lecture. So as you turn these in, these will be posted to Blackboard for your video solutions to your problems. You will also be grading the solutions from the other group to your problem as well. So now let's take a look at some of the milestones and due dates associated with our group project. So we come down here, we can see this first milestone. We've already completed this. You guys have formed your teams and submitted a list of the team members via Blackboard assignment. Again, these are 4 to 5 team members per team. So from this here, hopefully you guys have been working hard towards creating your problem, because that's the next milestone here. On Thursday, April 29th, this is when you're going to turn in that problem that you've created along with your solution. Now this will be done via a Blackboard assignment. And this Blackboard assignment is going to allow you to submit this as a group. So only one member of each of the teams will need to actually submit this assignment to me. As long as one of them's turned it in, they're all linked together through these teams that we've created on Blackboard. Then from there, the next milestone we have here is on Monday, May 3rd. This is when we're going to distribute your team's problem to another team to solve. So you're just going to be solving one other team's problem. So once you've completed that, your solution, you're going to submit your solution to the other team's problem back to them, and they're going to grade that for you. So you give the team that created the problem your solution to their problem that you've solved out, and this is going to be on Thursday, May 6th. And the last due date will be on Tuesday, May 11th, and this is when you're going to submit your final video presentation. So what this is going to be, this is going to be similar to like I do when I go through example problems in class. You're going to record a video of you going through your entire solution, explaining your solution, your thought process, relating it back to the governing equations, and all of that stuff included in your virtual presentation. This will be turned into Blackboard and graded as a portion of your group assignment. Now also on Tuesday, May 11th, not only be turning in your video presentation, but you'll also be turning in the graded work from the other teams that solved out your group's problems. And this will be submitted through Blackboard as well. So as we jump into our Module 13, the topic here we'll be looking at is our mass transfer. So in this module, we're going to take a look at the correlations of convection mass transfer coefficients associated with evaporation or sublimation from liquid or solid surfaces in external flow. And these may be inferred from corresponding heat transfer correlations for an isothermal surface by invoking the heat mass transfer analogy. So within this module, we'll take a look at that heat mass transfer analogy, take a look at flat plate and parallel flow, specifically looking at the laminar flow, the laminar to turbulent region, and the turbulent flow as well. So then the last topic we'll be taking a look at are fluid properties. So this relates back to chapter 7 in your book, sections 7.2 through 7.8. So we'll be breaking down module 13 into two different sections, 13.1 and 13.2. For module 13.1, this is your exam 2. So let's get into the details for our exam number 2. Exam 2 will cover materials from our textbook in chapters 3 through 6, which relates to our modules 6 through 12 in our lectures. So this is all fair game for this exam number 2. These exams will be released on Blackboard. So the date that they'll be released is Tuesday, April 27th. So please take note of this. The new date for this exam number 2 is Tuesday, April 27th. It will be released on Blackboard at 9 a.m. Now, once you start the exam, you will have 2 hours to complete it. And this is automated by Blackboard. So if you started at 9 a.m., it'll need to be turned in by 11 a.m. But I'm giving a 3-hour block. And the reason I'm doing this is for students that are coming from another class or going to another class. They have a little bit of leeway. So this right here will be due at the very latest at 12 p.m. So if you don't start the exam until 10 because you're coming from another class, you'll still have 2 hours, but it'll need to be done by 12 p.m. for that case. You'll submit your final work through Blackboard, and the format will be the same as you've seen on your homework and your previous exam number 1. So students without accommodations or scheduling conflicts are expected to complete the exam in that 3-hour block from 9 a.m. to 12 p.m. during that designated slot. And again, you only have 2 hours to complete it, but there is a 3-hour block. Now, if students do have accommodations, then extra time will be accommodated for them after 12 p.m. So if this is the case and you do have accommodations and it doesn't fit within this 9 to 12 period, please contact me individually and we'll make sure that you have the correct accommodations for you. Now, if you're a student with a scheduling conflict and need to start it later, this is possible, but please let me know in advance so we can schedule this. And again, you'll still only have a 2-hour block, and we'll still need to have this finished, in this case here, before 2 p.m. So this all needs to be done in the same day. I want to keep the same exam for all the students, so we're going to still use the same exam regardless of when you're taking it. So I want to keep that window very short. The other thing to note is if you are a student with an accommodation, you need more than the 2 hours, you can ignore the automated late thing, or if you're taking it outside of that normal block because you have a scheduling conflict, ignore the automatic late notification. The grader will be looking at this exam at the time you opened it and the time you submitted it to make sure it's within the correct 2-hour for the students without accommodations and whatever your accommodations are for students with the accommodations, and double checking that you are within that correct time block. So for our second section of Module 13, this is our Module 13.2, we're looking at the topic of external flow mass transfer. So within this, we're taking a look at the heat and mass transfer analogy, talking about fluid properties, and looking at a flat plate and parallel flow. So within this, we're going to go over the key theory for the above topics, talk about our governing equations, look at some practical applications, and then go through my hand solution to a couple of problems.